All right, so in this video, I'm going to continue to cover 4.9 mechanical vibration. So the last video, we saw the undamped and free mass spring system. Okay, so now in today in this video, we're going to see second case, damped free mass spring system. It means that the damping force is non-zero, and then free means the external force is still zero. Okay, so here damped means that D is not D, B, right? B is not equal to zero, and then free means the external force is a zero function. Okay, so differential equation then going to be my dot prime and then plus, and then by prime, and then plus ky is equal to zero. Okay, so we assume that n, b, k are positive real number. Okay? So now let's find out the general solution. Okay, so here Ox equation going to be mr squared plus br plus k is equal to 0. Right, so then the r going to be the applying the quadratic formula, then r going to be negative b plus minus square root b squared minus 4 mk, right, over 2m. Okay, so as you can see that what this Ox equation can have two distinct real number or just one real root or complex root depending on the sign of b squared minus 4mk, right? So in second case, damped free mass spring system, we have three sub cases. Okay, so under the case 2. Okay, so anyway, let me the break up this one as the real part and the imaginary part, kind of. Okay, so I know the b squared minus 4mk is positive, then they are going to have only two distinct real root, right? But so I want to just simplify more. Okay, so it's going to be negative b over 2m, and then plus minus 1 over 2m times the square root of b squared minus 4mk. Okay, so now case 1. Okay, case 1 under the case 2. Okay, so let me say subcase 1. So b squared minus 4mk, b squared is less than 4mk. Okay, I'm sorry. So what does that mean? B squared is less than 4mk. Then the Ox equation going to have two distinct real roots. Okay, I mean simple roots. Okay, so in that case, in engineering, it is called the underdamped mass spring system. Okay, underdamped mass spring system. Okay, all right. So since b squared is less than 4mk, oh, I'm sorry. So since b squared is less than 4mk, then the Ox equation has two distinct complex roots. Sorry, not real root. So and then we can express the root complex root of Ox equation as alpha plus minus I beta. Okay, we know what alpha and beta is. So alpha is a negative b over 2m, beta going to be what, 1 over 2m times that square root of what, that discriminant, right? So I mean, where alpha is equal to negative b over 2m, and then beta is equal to 1 over 2m times square root b squared minus 4mk. Okay, so now in that subcase, general solution y of t is going to be c1 times e to d alpha t, and then cosine, right, beta t. Okay, we know the form of general solution when Ox equation has the complex root. right? We studied the chapter 4.3, right? Plus C2 times e to the alpha t, and then sine beta t, right? Okay, now this is equal to, because e to the alpha t is kind of a common factor, right? So we're factoring out e to the alpha t, then we're going to have e to the alpha t times c1 times cosine beta t plus c2 times sine beta t, right? And then look at this. This is nothing but what? The general, that form is, this one is has the exactly same form as the what? The form of general solution in case 1, the undamped free mass spring system. We learned that, right, in the previous video. Okay, so then we could express this one as one single sine function, right? So this is equal to e to the alpha t, and then we can express C1 as a times sine phase angle pi, and then cosine beta t plus, or so we could say that we can say that C2 as a times cosine pi, and then sine beta t. If you don't get it, why we can say C1 as a times sine pi, and then C2 as a times cosine pi, just watch the video, the lecture video solving the homework problems. Um, yeah, I don't quite remember what problem number, but I think just look at the problem, the video explain how to solve the problem in homework set chapter 3. Okay, so then yeah, you can understand that. So now then this is equal to, now by the way, here we say C1 is this and the C2 is this, right? Okay, and then this one is equal to a times e to the alpha t, and then sine beta t, and then plus phase angle pi. And the key in mind is alpha is negative b over 2m, beta is 1 over 2m times square root b squared minus 4mk. Okay, so now okay, so we figure out general solution, and then what? By the way, so here the a is what? So now we're, the a is equal to square root c1 squared plus c2 squared, and then tangent pi is equal to c1 over c2. Okay, so now here a times e to the alpha t, this is called the exponential damping factor. Okay, I know in the case 1 on undamped free mass spring system, exponential term was not involved in a general solution. So a is the a was the amplitude, right? But now in this general solution, in case 2, since the exponential term is involved, so the amplitude is not constant as a, but as you can see that amplitude is what, decreasing as t is increased. Understand that? Why? Because alpha is what, negative b over 2m. And then what is b and m? M is mass, and then b is what? Inertia, right? So we assume that m, b, k, all three constants are positive real number. So sine of alpha is negative. So e to the alpha t is a decreasing function. So amplitude will should be decreased as t is increased. Okay, so this term is called the exponential damping factor. Okay, so this is called the exponential damping factor. Okay. What about the this one, sine beta t plus beta? This is just sine factor. I mean wave. Because of this factor, the motion of the object has the behavior of the vibration, right? But since the amplitude decrease, so the what vibration will be disappeared as t is approached, t is increased. Okay, So now, so we can say that what behavior of the oscillatory motion of y, t is what sine. The sine factor varies between -1 and 1 in the period. Going to be what 2 pi over beta. Okay. And then y of t varies between, I mean, here this one, and then y of t between -a times e to the alpha t, okay, and a times e to the alpha t with quasi period, okay. P is equal to 2 pi over beta. And then quasi frequency. 1 over P. So what does that mean? So I told you what? Since the e to the alpha t is decreasing function because the alpha is negative, right? Because b is positive and m is positive, so alpha is a negative. So this is a decreasing function. So in if you just draw the graph of the y of t, the graph must be what could be like this. Okay, so as you can see, the amplitude is decrease exponentially, right? Decrease, and then so in this case, the what the wave is not repeated, right? So we cannot use the terminology period or frequency. Instead of those terminology, we're gonna use quasi period and the quasi frequency. Okay. By the way, the what the dot the curve is the graph of a times e to the alpha t. Okay, and then this one must be -a times e to the alpha t. Right. Okay, and then for example from here to let me see here to this one, that's the quasi period. Okay, is equal to 2 pi over beta. Okay, so now anyway, so if we figured out that why the name of the subcase 1 is underdamped, because of the damping factor, what I mean damping force effect on the vibration of the y of t, I mean the object, right? So that's why the wave vibration, I mean the amplitude of vibration is decreased and eventually gone, right? Okay, and the next next subcase 2, okay, in this case b squared is greater than 4mk. It is called the overdamped. Okay, overdamped. Then the Ox equation gonna have two distinct root, I mean simple root, right? So R1 is equal to negative b over 2m plus 1 over 2m square root b squared minus 4mk, right? And then R2 is equal to negative b over 2m and then minus 1 over 2m square root b squared minus 4mk. Okay, so now look at this. B squared is, I mean, so let's figure out which one is greater than the other one, b squared and b squared minus 4mk. Okay, since b, keep in mind is all the constants b m k are positive. Okay, so b squared positive, 4mk positive, right? And then b squared was positive. Okay, all right. So then what? Since b squared minus, that means b squared minus 4mk must be less than b squared. It means that b squared is greater than b squared minus 4mk, isn't it? Okay. For example, b squared is 10. This is 10. Let's say 4mk is just 2. Then definitely 10 is greater than 10 minus 2, right? Okay. So then we take a square root on both sides, right? Then we can say what? The b implies b is greater than square root b squared minus 4mk. Okay. All right. So keep in mind this one. Okay. So now then, look at this. Now we can combine these two fractions, right? And then we can combine these two fractions. Then R1 gonna be negative b plus, right, square root b squared minus 4mk over 2m. And then look at this. Since we figured out b is greater than square root b squared minus 4mk, so negative b plus square root b squared minus 4mk, that numerator in R1 is gonna be negative. So R1 is negative. What about R2? Is equal to is negative b minus square root b squared minus 4mk over 2m. Or it's definitely negative, right? Okay, this is negative, right? So, all right, so it means that what? R1 is less than 0, R2 is less than 0. Then, and then we know the general, the form of general solution in this case. Y of t is what? C1 times e to the R1t, right? Plus C2 times e to the R2t. Then both functions, exponential functions, e to the R1t, e to the R2t, must be exponentially decreasing function, right? Okay, and then there is no sine or cosine functions involved. So we definitely this, the y of t doesn't have any vibration, behavior of the vibration. Okay, so the inertial y of t must approach 0 as t approaches infinity. Okay, so then what? The motion of the object in this case doesn't have any oscillation. Okay, so that's why the name of the steps of case 2 is overdamped, because then what the what the damping force is dominate other forces. Okay, so now you see here, okay, so now but let's figure out the graph of y of t, okay, briefly. So now then y of t is equal to, we figured out that C1 y of t is this, right? But let me express e to the R2t in terms of e to the R1t. Okay, so it means that we can say I'm sorry. So I know this is the decrease function, right? But I want to figure out the local maximum minimum. Okay, so let's find the derivative y, which is R1, and then C1 e to the R1t, and then plus R2 times C2 times e to the R2t. Okay, so to find our local maximum minimum, we have to find the critical value, right? So we have to solve this is equal 0, but before solving that equation that equals 0, let me simplify this one. So I want to factor out e to the R1t. Then we're going to get C1 times R1, and then plus C2 times R2, and then times e to the R2 minus R1 times t. Is it? Okay. All right. So we know the e to the R1t is always positive for any t. Okay. Okay. And then this is always positive, right? Okay. So depending on the C1 and C2, y prime gonna have a root, or the y prime not gonna have a root, it means that what? Y of t has at most a local maximum or minimum. Okay, so this one has y of t has at most maximum or minimum. Okay, so this is positive. This is positive, right? Okay, so depending on C1, C2, this y prime probably can have the a root, or don't have a root, or I mean have root. Okay, so that's why we got this. So now then, what? So what if this y prime, I mean the yta doesn't have critical values? Then the t, then graph must be a b. I mean graph of y of t must be like this. Okay, so no local maximum, minimum. Okay, case one. So what if yt has a local, I mean critical value, and then at the critical value y of t has a maximum value, then y of t has one local maximum. The graph must be like this. Okay, this is y, here's y right there, and then one local maximum. Okay, if the yt has one local minimum, then graph must be like this. Okay, so one local minimum. Okay. Now, last subcase. 3, and then guess what? B squared is equal to 4mk. Okay. So in this case, in engineering, is called the critical damped system. Critical damped system. Okay. So definitely the Ox equation has one real root. It's called the double root, right? So r is equal to negative b over 2m. Okay. Then the general solution is going to be what? C1 times e to the r t, right, plus C2 times e to d, C2 times t times, right, e to the rt, right? So since b and m are positive, so negative b over 2m is less than 0, well, we figured out that in subcase 2, right? So y prime, and then now we want to figure out the behavior of the y of t, okay? So the what? Since the e to the rt and the e to the rt is decreasing functions, right? Because r negative b over 2m is less than 0. Okay, so y of t, definitely y of t approach 0. So y of t approach 0 as t approach infinity. Okay, right? And then we're gonna figure out the whether or not this guy has any local max and minimum, right? So then like the subcase 2, we're gonna find the y prime, which is e to the rt, and the c1 r plus c2 plus c2 times t times r, right? Okay, so now then, c1 times r plus c2 plus c2 t r equals, we solve that equation, right, to find the critical value, right? Then what, definitely this one has only one solution, right? Okay, so y of t has one critical value. It means that yt has at most one local maximum or minimum. Okay, so like the subcase 2, the motion of y of t is non-oscillatory. Okay, right? So in subcase 3, so we're gonna have the graph yt is like has 3 cases. This one, this one, this one. Okay, so let's see example. Okay, let's see. So example, right? So Think about the, let's consider the free mass spring system is governed by this one, y. That example is my lecture note, okay? Y dot prime plus by prime plus 25y is equal to 0. And then y of 0 is equal to 1, and then y prime 0 is equal to 0. Okay, so y of 0, 1, it means that what? Initial position, right? Okay, y prime 0, this is initial velocity, right? Okay, and then 0 in the right hand side, the 0 in the governing equation means that what? External force is 0 function, okay? All right. So and then the mass is 1, and then spring constant stiffness is 25, and then question is this: find the equation of motion for the 3 cases. Okay, why they find the equation of motion for 3 cases: b equals 6 and 10 and 12. Okay, all right. So let's do this. So solution. We're gonna find out Ox equation. I'm gonna find out the root of Ox equation first. Okay, so the Ox equation gonna be r squared plus br plus 25 equals 0, right? Okay, then r gonna be what? Minus b plus minus square root b squared minus 100 over 2, isn't it? Okay, so here, from here we can figure out the m equals 1, right? And then here's a b, right? And then k is 25, right? So b squared minus 4mk, which means that 4 times 1 times 25, which is 100. Okay. So now case 1. Okay, b equals 6. Okay, b equals 6. In that case, what? Then b squared, which is 36, right? And the 4mk is what? 100, right? Okay, definitely 36 is less than 100. So it means, which means that the v equals 6, then we're gonna get what? I mean, this governing equation turns out to be what? Underdamped. Right? So this is underdamped. Okay. So now then, r gonna be what? The negative. Give me a second. Negative b over. Let me see. Negative b over 2, and then plus minus, and then square root b squared minus 100 over 2, right? That is equal to. We're gonna plug in 6 into b, so we're gonna get the negative 3 and the plus minus, and then 4i. Okay, so alpha equals negative 3, and the beta is equal to 4. Right? So the general solution gonna be what? C1 times e to the alpha t, which is negative 3t, and then cosine 4t, right? And then plus C2 times e to the negative 3t, and then sine 4t, right? Right. So let's find out C1 and C2, okay? And then we're gonna simplify this one as the what? The one single sine form, okay? So the we're gonna impose the initial condition y of 0, which is the C1 times what, when t equals 0, then cosine 0, 1. So we're gonna get C1, right? By the way, e to the 0 is 1, right? E to the 0, 1. The sine 0, 0. So we got C1. That must be equal to 1, right? So C1 is equal to 1. Then what about y prime? To impose y prime 0 equals 0, we need to find out derivative y. Okay, that's going to be C, what, y prime d0 going to be what? C, well, negative 3 times. The key mind is, so to find the derivative of y, we need to apply the product rule for each terms, right? Okay, so we got negative 3 times C1 times e to the negative 3t, then cosine 4t, Okay, and then minus 4 times C1 times e to negative 3t, and then sine 4t, right? Because derivative cosine 4t is a negative 4 times sine 4t. Okay, and then minus 3 times C2 times e to the negative 3t, and then sine 4t. Why? Because what I'm doing, I'm just taking the derivative of second term, okay, using the product rule, okay? So now then what? Derivative of e to negative 3t going to be negative 3 times c2 times e to negative 3t, right? And then plus derivative of sine 4t is a 4 times c2 times and the e to negative 3t and then cosine 4t, okay? So now we're going to plug in 0 into t. Then y prime 0, this is going to be, you see, all of these sine term going to be 0. Why? Because sine 0 is 0, okay? This is 0. This is 0. The all of cosine term, cosine going to be 1, okay? So cosine 0, 1, cosine 0, 1, and then all of exponential terms going to be 1, okay? It's a 1, 1, 1, 1, okay? Now, then what term is going to be left? Negative 3c1, right? Negative 3c1, and then what? Plus 4 times c2. That must be equal to what? That must be equal to 0, okay? Then we plug in 1 into c1. Then c2 must be what? Uh, 3 over 4, right? So c2 going to be 3/4. Okay. Now we plug in these two, value on the constant unknown constant integration into the general solution. Okay. So dy of t is equal to e to the negative 3t and then cosine 4t, okay, plus 3 over 4 e to the negative 3t and then sine 4t. Okay. So now then what? Well, now we're gonna express this one, simplify that one as one single sine term. Okay, a times e to the negative 3t, and then sine, oops, is sine, and then 4t plus p's angle pi. So now what is a? A is square root c1 squared plus c2 squared, right? Which is what? 5 over 4. Okay, and then tangent pi is equal to c1 over c2, which is 4 over 3. Okay, now what? C1, if you want to figure out the pi phase angle pi is going to be what? Arctangent, right? Of 4 over 3. Okay, and then what the key in mind is the phase angle pi must be between 0 and 90 degree. Okay, I mean 0 to pi over 2 radian. Why? Because C1 and C2 are positive. Okay, so remember that in this case this is C1 and this is C2. All right. So if C1 and C2 positive, the phase angle pi between 0 and pi over 2. Okay, and then C1 is negative and C2 positive, then phase angle pi between pi over 2 to pi. Okay, and then C2 is negative, but C1 is also negative, then phase angle pi must be between pi and the 3 pi over 2, and then 3 pi over 2 to 2 pi if C1 is positive, C2 negative. Keep in mind this. Okay, so now then okay, then this is approximately 0.9273. Keep in mind this. So we got the solution. Y of t is equal to what? 5 over 4 e to negative 3t, and then sine the 4t plus 0.9273. Okay. All right. So now the give me a second. Let me do sub case 2. Okay. So b is b not sub case. Second case, b equals 10. B is equals 10. If b equals 10, then b squared going to be 100, okay? And the 4mk was 100, right? So B squared is equal to 4mk, right? So that's the critical depth, right? Okay. So critical depth, then the R gonna be what? Give me a second. Let's see. These two R. The critical depth R was what? Negative B over 2m, and then plus minus 1 over 2m square root B squared minus 4mk, right? So since the B squared minus 4mk should be 0 when B equals 10, so this term going to be gone. So this is equal to negative B over 2m. So the Ox equation has one real root. I mean, Ox equation has a simple root, a double root. I'm sorry, double root. All right, so now then general solution y of t going to be what? C1 times e to the rt plus C2 times t times e to the rt, right? Okay, so that was the, then let's find out C1 and C2, okay? And then I'm going to plug in negative b of 2m later, okay? So then y of 0 is going to be what? C1 plus, C1 times e to the 0, which is 1, okay, plus C2 times 0 times, so second term is gone, right, when t equals 0. So that must be equal to 1, right? Because the initial position was 1, yeah, C1 is equal to 1, okay? And then we find out derivative y. It's going to be C1 times R times e to the RT, and then plus C2 times e to the RT, and then plus C2 times R times T times e to the RT, okay? And now I'm plugging 0 into T, then what? All of the exponential term going to be 1, and then this guy going to be 0. So the third term is going to be gone, and then we're going to get C1 R plus C2. That must be equal to 0, right? Okay. Right. Now then, what? Let me see. Okay. So now the y prime, so C2, since C1 is 1, right? So we're going to get this, R plus C2 equals 0. So it means that what? C2 is equal to negative R, right? Okay. So now y of t is equal to C1 times, what is R? Negative b over 2m. Here, negative b over 2m is what? B is 10, and then m is what? 1, right? So we got negative 10 over 2, which is negative 5, right? So C1 times e to the negative 5t, okay? And then plus, and C2, but C2 is negative R, which is a 5, right? Plus 5 times t times e to the negative 5t. Okay. So now then, this is equal to e to the negative, we just factor out e to the negative 5, then we got the, C1 is 1, right? Sorry, this is 1, sorry. So e to the negative 5t times 1 plus 5t. All right? Okay. All right. So now, and then let's find out then, let's try to plot the graph of y of t. Okay. So by finding critical values, local maximum, minimum. You don't have to, but yeah, I'll just want to figure out roughly the graph of y of t. Okay. So then y prime, let me write here. So y prime t is going to be negative, right? 5 times e is equal to negative 5 times e to the negative 5t, 1 plus 5t, and then plus 5 times e to the negative 5t. Okay. So now this is equal to what? Because negative 5 times e to the negative 5t, and then plus 5 times e to the negative 5t, gonna be cancel them out. So we got what? Negative 25 t times e to the negative 5t, isn't it? So when t equals 0, y prime 0. So 0 is the only the critical value, right? then this is decreasing function. So we can see that graph must be what? Like this. Okay. This is here t, this is y. So this is graph of y of t. And right here, this is critical value, I mean local maximum. So now the sub case 3, let me skip the sub case, I mean the case that b equals 16. I'm sure that you can do by yourself. Okay, this is similar to that solution, second case. Okay, so this is the section 4. Chapter 4, section 4.9. I just covered that. Okay, and then next time what I'm gonna next time I'm gonna cover the chapter 7. Okay, so let me stop here. Any question? Just send email to me, or just contact me through the Blackboard. Okay, so you have any trouble, any question about the online homework, then just let me know. Then I'll give some kind of hint. All right, let me stop here.